So for question 17, we look at our question 17. Keyword that y is in terms of u, and then u is in terms of x. Find the first derivative, hence find the value of d2y dx squared at the point of x equals to 0. So we have three variables here. Look at here, we have three variables. We have variable y, we have variable u, and then we have variable x. So this one is parametric. So you look at it carefully. Y is in terms of u is in terms of x. So seems like this u can be substituted. Is parametric means x in terms of t, y in terms of t. That will be our parametric because we have three variables x, t, and y. So y in terms of third party variable, x in terms of third party variable. That will be our parametric differentiation. So for this question, actually is not our parametric. Actually, they can simplify. Once they give us u, means our u's, you can see our u can be simplified. You can substitute back. Once you substitute back, actually our y is just in terms of x. So this question just want to test you whether you understand the parametric or not, whether you can see the question clearly or not. So we're going to try to substitute so that we can express y in terms of x. So substitute this u, which is square root of x squared plus 2. Okay, so substitute this u inside here. And then square root and square. Simplify. Square root and square, simplify. So actually, our y is in terms of x, and this is explicit, which is x squared plus 1 over x squared plus 3. Because this one, 2 minus 1, we get 1. 2 plus 1, we get 3. So we only going to differentiate it explicitly. And then we can see our function of x here. Our function of x here is quadratic over quadratic, so this is rational. Okay, so this is our quotient rule we'll be doing. So differentiate this y equation in quotient rule. Set up our quotient rule. Salin yang bawah, differentiate yang atas, tolak. Salin yang atas, differentiate yang bawah. Then yang bawah square. So it will be more easier. So differentiate yang salin yang bawah, differentiate yang atas, differentiate x square, power move to the front, power minus 1. Differentiate numbers, we get positive 0. And then salin yang atas, differentiate yang bawah, so this is 2x. Then plus 3, differentiate 3 is 0. So from here, we can simplify some more. Alright, so we have to factorize it. So always practice your skill of factorize. So you can see our same factor here. Our same factor here is 2x. So we're going to factorize our 2x in order to make us simplify this easier. So for the first term here, after we factorize this 2x, we get x squared plus 3. For this, at 2x we factorize, we get minus x squared minus 1. So don't forget this negative. We have to simplify it together. Negative x squared, negative 1. And then x squared minus x squared managed to simplify. So finally, constant here is 3 minus 1, 2. 2 times 2 is 4. Okay, so that will be our first task of this question, find dy dx. After that, we're going to find second derivative where x equals to 0. So based on our result from our first derivative, we look at our variable x here in quotient rule, in quotient linear x, quadratic x. So two function divide, quotient rule we're going to apply. Quotient rule for this second derivative test again. So set up our quotient rule. Salin yang bawah differentiate yang atas, tolak, salin yang atas, differentiate yang bawah. So this bawah is quite complicated. Give more space. And then divide by denominator square. So square and square become power 4. Okay, square and square become power 4. Okay, differentiate the part that we want. Salin yang bawah, differentiate yang atas. Differentiate 4x, leaving the coefficient 4. So salin yang atas, differentiate yang bawah. So bawah ni in the bracket of power. In the bracket of power, when you want to differentiate this part, is a power rule. So what's power rule say? Power turun depan, power tolak 1, differentiate dalam kurungan. Okay, yang differentiate dalam kurungan ni adalah power rule. So differentiate dalam kurungan, differentiate x square, we get 2x. Differentiate 3, we plus 0. So finish. So don't worry, we're not going to simplify this because you read our question carefully here. They say hence, find the second derivative, find the value. What we need to obtain is the value. It's not the expression of d2y dx squared at the point of x equals to 0. Okay, so we don't need to simplify this. Straight away, we can substitute, as the question said, find the value. So we can straight away substitute x equals to 0 to find out what is our second derivative value. So when this 0 square plus 9, plus 3 square is 9 times 4. And then this one 0, multiply with everything 0, divide by. So this one is 0, 3, 3 power 4. So figure this out. It will be 4/9.